So, actually, we have here last week, Thursday, and that would have been day 10, and the students took the exam. Exam 1, basically over chapters 1 through 6 in the curriculum. And so now we are on Tuesday. NET-136, Operating Systems 2, Linux. Today we talked about memory management, did some work files and directories, talked a little bit about pipes, redirection, and kind of lead up to scripts. So, first of all, let's talk about a little bit. So we started off, I started off talking in general about memory. So we drew this, talked about memory, and then we talked about storage. Distinguish between the two. We talked about hard drives and solid state storage, solid state drives, flash and magnetic. Talked about some of the advantages and disadvantages. And we got speed, but some concerns with how long it lasts. Good performance here, and magnetic lasts a long time, unless you get near magnetic fields and so forth. But anyway, we talked about storage. And of course, storage is connected to the bus, which connects all these things together. Talked a little bit about CPU, the most important resource that the operating system has to manage, and memory is the second most important resource that the operating system has to manage. Then, inside, we have processes, right? Using up memory. And so we talked a little bit about that. So, review, talked about source code compiled into object code. This is something the computer can work with, okay? Machine language. Then we link in other libraries and we get executable code. So what we talked about today was rather than this whole process happening at once, creating executable code, we can take the object code, let's say that process is running in here, and then we can have a shared area for linking to some particular library. The example I used was printing. You may have something from a library that allows to print, the code that allows the computer to print, and that could be in memory, and multiple processes that's in memory can use that shared place for code. So it's a more efficient way of handling memory. Alright, then we also talked about, let's just do it in red, a swap file or a page file. We didn't talk a whole lot about the differences or how those are termed. More on that later, but it's referred to as virtual memory. It's a space on the hard drive, contiguous, in which some of the code from your process can be stored here, or your processes, and then that can be swapped in and out. Or it used to be the idea you'd have your code divided up into pages, and some pages would be in memory and those would be processed, and then you could swap out a page and bring another one in. Alright, to finish up here, we talked about keeping a CPU busy, like if we had a clock speed 3.8 billion cycles, 3.8 billion ticks a second in the computer. And so we can literally, like the process of instruction might take 8 steps. Okay, between getting the instruction, let's just look at an example, getting the instruction here, getting it up into a register, bringing up the data, actually interpreting the instruction, processing it, then sending the information back to memory. But even 8 steps, and you got a clock that's running 3.8 billion times a second, you can still actually perform millions of instructions a second. And on a PC. Little review. Students working in the curriculum on the theory part, and we talked a little bit about the labs. So the labs now, we are pretty close to being up through 8, and we're going to start scripts, chapter 9. So students need to be working on this, and I mentioned in the theory part, you may have to take some notes, go through things a couple times to make sure you're catching and understanding the theory. Just glancing through it or reading it once might not be enough. I looked through the work turned in on the GUI. Remember, really our goal there was just to experience, do enough work in it so you have an idea what it looks like, and then you can basically find the different things in there. CLI, today, more work, files and directories. We compressed and copied some information, actually copied it from one machine to another, and we got started on a few pipes and redirection. Took some information and redirected it to a file. Okay, pretty hard to simulate here in the notes, but let's just talk briefly about them. We reviewed relative and absolute addressing. This has to do with not addressing, but relative and absolute access to directories. Talked a little bit about the hierarchy. You got the root or the top of the directory, and you have all these here, and then they break down. And we talked about moving around. Catenation cat, we looked at a file. If you want to know more about it, we talked about man. We talked about creating a backup. So what we did was we used tar, and we compressed the public HTML directory. Then we used secure copy, copied it from a hard drive in one computer to the hard drive in another computer. So we had a compressed file here, copied it over here. Then we talked about looking at it and decompressing it, or extracting it, unzip it, however you might want to term that. Talked about secure copy, preserve the dates and so forth. This was the file, this was the remote machine, remember the colon, and then the directory you want to copy it to. We did some work last. We took that and we redirected into a file name, change mode. We did a, let me give an example here. We did a change mode on a directory 777. On Thursday I will talk about what those numbers mean. And it allowed then for everybody to copy information. We created a shared directory on machine, and we had all the students copy files into that same directory. Talked about redirect and append, and we talked about the grep. We used it where we did a command, we piped it to the grep, and we looked for something in particular. So, that is it for today. Make sure you let me know if you have questions.